Okay, so this is an HL question. We have a diagram over here. It's telling us that we have a mass, 2 kilograms, traveling at a speed of 5 meters per second, which is this object. It collides with a mass of 4 kilograms over here, traveling at a speed of 3 meters per second. Okay, and they also collide at right angles, hence you see the arrows here. So this object moves to the right, this object moves up. They collide at exactly this point, which happens to be 90 degrees to each other. Okay, and as a result, they join and then they move together after the collision at an angle theta to the original direction of this object over here, the 2 kilogram object. And hence we have the angle above the horizontal, and this now is the combined object. Okay, so the question is, what is that angle above the horizontal in which they collide and move in the direction of? Okay, well, first of all, we do want to figure out what would be the mass of this object over here. Okay, well, because we are combining the 2 and the 4, then at this object here will actually have a combined mass of 6 kilograms. Okay, and then what else can we recognize? Well, if I were to extend this, okay, like that, notice that I now have a Cartesian plane, and I am focused now on this angle, or not this vector, this line over here. And as I always say, whenever you have a diagonal line, okay, this is a result of your horizontal and vertical components. Okay, and now because we also have an angle involved, okay, then we have the cosine and the sine. Okay, that gets thrown into this analysis now. So for the horizontal component, okay, I'm going to label this as your v cosine theta. All right, and then my vertical component is now going to be my v sine of theta. All right, so those are the parts I'm going to consider. Now, this is an example here of momentum, all right, in which my momentum, given by the formula m times v, so the mass of the object times the speed of the object, the v in the expressions I wrote, will actually give me a certain constant. All right, so this is kind of the general idea that I'm working with right now. So how can I go about this problem given the information that I have? Well, I'm first going to begin with the first object here. Okay, so prior to the collision, I have the object that weighs 2 kilograms, okay, traveling at a speed of 5 meters per second. So hence this will become 2 times 5. Now what does that equal? Okay, well, the horizontal component, that is going to equal v cosine of the angle, okay, multiplied by the mass after the collision. And after the collision, the object now weighs 6 kilograms. Okay, so just to be clear, whenever you have a setup like this, whenever you have collisions, okay, usually we will set it up such that the first part of the equation represents the situation before the collision here. So before the collision, the mass was just 2 kilograms traveling at a speed of 5 meters per second. But then after the collision, analyzing the horizontal component, the object now is at v, at a certain speed v, cosine of the angle, with a mass of 6 because the objects combined. Okay, now this is for the horizontal component. For the vertical component, we are going to take into account this object here. Okay, so here, before the collision, this object weighed 4 kilograms. It was traveling at a speed of 3 meters per second. And then after the collision, it now is v sine, okay, of the angle multiplied by the mass, which is 6 because they combined. Okay, now moving forward, there are actually two ways you can solve this. Okay, the faster way is to just label your equation. So this I will label to be equation 1, and then this here I will label to be equation 2. And what I can do is I can just divide the two equations. Okay, if I do that, okay, if I divide equation 2 divided by equation 1, okay, I will have the following. I'll have 4 multiplied by 3 over 2 multiplied by 5 equals v sine theta of 6 over v cosine theta of 6. Okay, now if I simplify this, okay, this is 12, this is 10. 12 divided by 10 simplifies to 6 over 5. All right, here my 6's cancel, v's cancel. Sine over cosine, okay, trigonometric identity, is this is actually going to equal to tangent of theta. All right, and notice that the question is asking us here to find that value for theta. Okay, well, if you recognize that this is a number bigger than 1, so actually this is, if you calculate, around 1.2, okay, equals tangent of theta. What is the value for theta here? Well, if you remember, okay, recall that tangent of 45 degrees is equal to 1. So if this is a value that's slightly bigger than 1, then I can expect my angle, my corresponding theta value, to be slightly, okay, but not too much, bigger or greater than 45 degrees. So if you look at your choices, all right, 34 and 37 definitely are out of the picture already because those are smaller than 45 degrees. So the question is it going to be 50 or 56? Well, it goes back to what I said a while ago. Because this is 1.2, only slightly greater than 1, okay, we will lean towards the 50 degrees, okay, because that's more accurate. 56 would be too big, okay? So you would have to kind of estimate if you want to do it through a matter of estimation. You can also double check, okay? In your calculators, you would put tangent inverse of 1.2, and you should get a value for theta here that is roughly close to 50 degrees. Hence, the answer is letter C. Okay. Now, if you're wondering why did we divide? Okay, why did we divide 2 divided by 1? Okay. Well, you could do it a longer way. All right. Well, and I'll just do it here at the bottom for those of you who want clarification in that regard. Well, I'm going to rewrite my 2 equations. Okay, like this. And then equation 2 is as such. Okay. Now, I can set these two equal to each other. Okay. What do they have in common? Okay. Both of these equations have 6 in common. Okay. So if I want to isolate 6, okay, that's going to be 2 times 5 divided by v cosine of theta. Okay, and then for the second one, I could also do the same thing. 6 is equal to 4 times 3 over v sine theta. Now, because they are now both equal to 6, I can equate these 2 equations to each other. All right, so that will look like 4 times 3 over v sine theta over 2 times 5 v cosine theta. And by isolating things here and getting theta by itself, I will still be able to get the answer. So I'll show that to you if you will. So this is going to be cross multiplication. So 2 times 5 is 10 multiplied, okay, that's how it looks like, by v sine theta equals this one, which is 12 multiplied by v cosine of theta. Okay. Now, by moving things around, I'll do v sine theta over v cosine theta is going to equal 12 over 10, which is equal to 6 over 5. All right? But then again, this cancels and simplifies to tangent of theta equals 6.5, which we said earlier is equal to 1.2. And notice how I arrived at the same place. Okay, this is just a bit longer, but if it's unclear to you, if you're not comfortable with just going straight to dividing the 2 equations, if you didn't recognize the relationship early on and you did this long method, you will still arrive at the same answer of roughly 50 degrees. Hence, the answer is letter C. Okay, now before we end, if you're wondering, well, what if I were to flip this, right? What if I did cosine over sine? Well, if you are familiar with your trigonometric identities, you know that, you can kind of like cheat your way through, if you will, because you know that sine over cosine is tangent, right? So why not just do that? Because you know that you'll be able to simplify the problem, and you know that there is a value for sine over cosine, which gives you tangent, right? So that's just an additional note there, but that is how you would do a problem like this.